Good afternoon, dear conference participants. My name is Natalia Mifronova. I work as Associate Professor at the National University Zaporizhia Polytechnic. This report is devoted to the improving aircraft engine compressor blade finishing. Blades are the most loaded parts of the modern gas turbine engine. Every blade manufacturing company researches, develops and improves technologies for the finishing stage in order to automate the process, ensure a favorable combination of surface layer properties and increase productivity. The blades are labor-intensive and a large part of the machining process consists in finishing operations. The finishing processing ensures a favorable combination of surface quality and surface layer properties. In addition to this, it can also lead to technological stress concentrators such as marks, scratches, microdents, etc. For blades, the airfoil of which are produced by the Rave new high-speed milling methods, finishing processing technologies have to take into account technological heredity. This is due to the specific micro-relief of the surface, namely the so-called seams that remain after HSM processing. Their size, shape, and frequency of location depend on conditions and modes of HSM. Temporary methods, hand polishing, had a low productivity and the need for additional finishing. One perspective finishing processing method for removing seams after finishing HSM is vibro polishing. The qualitative leap in the development of this method, equipment, and availability of the variety of abrasive fillers makes it impossible to achieve the required results. The purpose of this study was to establish the rational modes of vibro-abrasive polishing of gas turbine engine blade airfoil after HSM, to study the surface condition and its influence on the blade fatigue resistance. Studies were carried out on compressor blades made of titanium alloy VT8 and nickel alloy in Cornell 718. The finishing processing of examined blades was carried out manually on a jet machine. It was basic technology at the time of starting the research. Electrocorundum grinding wheels with grift size F80 and F180 were used successfully. The finishing processing of examined blades was carried out in automatic mode using vibration abrasion machines, Roslin film. A vibro-abrasive processing with different filler materials was carried out with the specified modes. The following investigations were carried out. The condition of surfaces, the airfoil surface roughness parameters before and after polishing, the degree of surface hardening, residual stresses arising in the surface layer during finishing processing. The endurance strength as the main operational parameters of blades. Visual examination of the processed surface by all methods indicated that after manual polishing, micro defects in the form of grooves were observed. Such defects can lead to the formation of fatigue microcracks. No micro defects were found on the processing surface after vibro-abrasive processing. Residual traces of milling seams were observed on the blade airfoil profile surface after 1.5 hours of vibro-abrasive processing. Then the processing time was increased to 3 hours, the number of traces absorbed decreased. And after 5 hours of the fiber abrasive polishing, there were no seams and the surface had a constant characteristic micro relief. The roughness measurement results for the blade profile surface before and after the finishing process are presented as a profile graph for the different machining options. Fiber abrasive polishing tasks from 3 to 5 hours to achieve the requirement roughness 0.2 micrometers. The macro hardness measurements show that the degree of surface hardening after manual polishing had practically no change, and after the fiber abrasive polishing was from 12 to 20%. The depth of the hammer hardened layer increased approximately threefold. Residual stress became more favorable after the fiber abrasive polishing process. The compressive stress appeared in the surface layer. The graph of the residual stresses of the blades under investigation after finishing with various options shows that the maximum residual stresses were observed on the blade surface. Based on the results of the surface roughness parameters and properties of the surface layers of the blade airfoil, it was found that the high quality and favorable properties of the surface layer of the blades under study were obtained by fiber abrasive polishing for 5 hours. In terms of productivity, it has to be considered that manual polishing time per blade varies about 1 hour. The fiber abrasive processing simultaneously allows to polish a set from 40 to 100 blades for 5 hours, which gives an increase in productivity from 6 to 25 times compared to the manual polishing. The test of fatigue limit showed that obtained endurance limit of the blades after fiber abrasive processing was on average 1.15 times higher than after manual polishing. The main reason for the increased fatigue life for the blades examined as a result of fiber abrasive polishing is the improvement of the main parameters of the surface layer of the airfoil, which are roughness, surface hardening, and residual stresses. Reducing roughness and eliminate seams marks after milling, technological stress concentrators, and the imposition of a compressor residual stresses increase the blade cycle loading bearing capacity. The following conclusion can be made from this study. Fiber abrasive polishing is a promising method for removing seams of the compressor blades. Thus eliminate the need for manual labors in the finishing stage. The obtained parameters of roughness, surface hardening, and distribution of residual stress along the depth of surface layer of blades from titanium alloy VT8 and nickel alloy in Connell 717 enabled to determine the original duration of fiber abrasive polishing that was 5 hours. The effect of fiber abrasive polishing on the fatigue strength of blades has been established. On the average endurance limit of blades after fiber abrasive polishing is 1.15 times higher than after manual polishing and made 460 megapascal. The use of fiber abrasive polishing of the blade airfoil after semi-finishing with HSM allows an increase in finishing productivity from 6 to 25 times, depending on the number of the blades in the set. Many thanks for your attention.